myself first. I can see the screen now. The title of the course is Electromagnetic. And Deepa Venkatesh. I am an assistant professor in the Department of Electrical Engineering. IIT Madras. And I'm given this task to talk to you about 16 lectures on electromagnetics. I have a question here for the technical staff. Can I see one of the colleges all the time on the video, but when I screen share, I wouldn't be able to see. I would like to see one of the colleges at least. So can you connect another laptop and connect to the video, at least one classroom? You can do that, right? Okay, so coming back, this moment I do not know how many of you are able to listen to me. I'm just blindly talking, assuming that there are people listening to me. There are, okay, the QEEE team suggests that those who are able to hear me, can you please hand raise in your software? Hear me? Can you please hand raise? See? I actually do not want to start interacting with them. I want to make sure. No, I have seen their video. I just want to make sure that because I am talking into my face, I want to make sure that there's a classroom in front of me, and I had requested this before. You can maybe log in as QEEE from the QEEE side and connect to one college and just put it onto one of the videos. Having UIET, VCAP, hand raising, so I know that there are at least some people listening to me. And I have the audio clear. I have GIT also. Okay, so I have a few colleges. PGS, PGCT says it's not publishing the video. So can you please enable your video? GCT. I see the GCT classroom here. Can you hear me?
Hello.
Yes, madam, we are able to hear you from GCT.
Yeah, okay. So are you able to see screen shared version? I wrote something on the screen. Were you able to see that?
Yeah, we are able to see you clearly, and the audio is also clear from GCT.
Okay, thank you. Yeah, thank you. VCAP?
Yes, ma'am. We are able to see you.
Can you hear me?
Yes, ma'am. We are able to hear you.
Okay, are you able to see the screen also?
Yes,
What I
ma'am.
wrote on the screen? Okay, fine, good.
ऊपर को है पूरा ठीक है ठीक है ठीक है
Yes,
madam. Audio quality is not good.
okay. So, can you turn mic on talk?
I cannot hear you properly. That audio quality.
I can hear you properly.
Is the quality good?
Okay, so what to do now, we will do a very introductory session today because many classes are still joining us. So let me go back to the screen. As I introduce myself, my name is Deepa. I am from the Electrical Engineering Department in IIT Madras. And my job is to deliver about 16 to 18 lectures on electromagnetics. I have circulated a syllabus. This is probably not following the syllabus or respective universities, but the motivation for this course is to get you, the students interested in the subject of electromagnetics, and to introduce you to some basics of electromagnetics. Typically, an electromagnetic course in most of the textbooks would start with a scalar field, a vector field, a gradient, divergence, curl, and so on. But what happens is by the time the student reaches the point where he is introduced Maxwell's equations, which are the pillars of the electromagnetics, the whole relevance is lost. It becomes very ceremonial then to go through the motion of dealing with so many such equations. So the way we want to do this is the following. We would first try to motivate why somebody should learn electromagnetics. We would then start from circuit theory, which I'm sure all the students have gone through in their first or second semester of their engineering curriculum. Starting from concepts like resistance, inductance, capacitance, the circuit model, and then we will see why the circuit theory is, or I should say why and where does the circuit theory fail, and why do we need electromagnetics in the electrical engineering subject. I'm sure electromagnetics is a very salient subject in physics, but as an engineer, why would you need the concept of E field and H field? Then we go on to Maxwell's equations. In the static case and for the time varying case, in the static case, we would talk about the basic concepts of field, potential. We'll talk about Gauss law, some of those contents that are familiar to you in your syllabus. some of your syllabus. Then we will talk about time varying fields. What happens when the electric field changes as a function of time? How does it affect the magnetic field and vice versa? As in, how does a change in magnetic field would change the electric field? And what is the consequence of the changing electric and magnetic field? What does it do to the system? So we will spend a bit of time here. Beyond that, we would go ahead doing boundary conditions. The end of this section on Maxwell's equation is when you have a time varying electric field and a time varying magnetic field under some conditions, you can generate a wave, which is an electromagnetic wave, which Maxwell predicted through his mathematical equations. Even science where the occurrence of the wave is predicted before it was discovered. So Heinrich Hertz later on, how do these waves propagate? What does medium do to the waves? And what happens, for example, when it boundary? See, what they have given me is wireless mic. So if you have realized, this sound that I am producing, my vocal cords are producing, is converted to an electrical signal at this microphone. This is a time varying signal. It's getting radiated this antenna, which means this moment as I am speaking, I have electromagnetic wave that is coming out of this mic, this antenna. It's coming, it's just that I can't see it. Now these waves are supposed to be directed towards a receiver sitting somewhere here. But these waves, see, this antenna is not a very directional antenna. You can still hear me in whichever direction I am turning it, which means these waves are actually hitting the walls. The question is, what happens when these waves hit the wall, a boundary? Do they reflect? Do they absorb? Does it go to the next studio? Would the students sitting in the next classroom hear me? That is all decided by the boundary conditions. So we will see in detail what happens to the electromagnetic waves when it hits the boundary. Question you might want to ask again is, okay, would it depend on the frequency of the wave that is going in? Would it depend on the polarization of the wave that is hitting? All that is going to get answered in this boundary conditions section. It is a very important section in electromagnetics because we always are working with boundaries, right? Beyond that, we will talk about wave propagation. Some other details of wave propagation. We will discuss Einstein's theorem, which is again a very fundamental and useful theorem in electromagnetics, because it is this theorem that will tell you how much energy is carried by the electromagnetic. I have generated electromagnetic wave from my light source or from this antenna, but what is the power carried by the wave? For example, you have light from the sun reaching you. Now, is there a way to calculate what is the power carried by the radiation? So all that will get answered here. And as we go, what I would do, also try to do, is to give you as many examples as possible. So, coming back to motivation. At this moment, I would like to interact with one of the colleges which has had a very good connection, CEM maybe. So CEM, I'm going to start interacting with. So CEM college, I want you to heartbeat. Okay, CEM, so the audio is not clear.
Okay, ma'am. Can you hear me? Hello?
I
उनका भी ये होता है ना
CE Pune.
होता है मिस्टेक से तो होता
I
है
don't see anybody there in CE Pune.
अभी ये थोड़ा क्या
Try ECT. Oh, there I can see a bunch of space there. GCT. Did you hear me? Can you turn on mic, please?
Yeah, we are able to hear you.
Okay. I want the class to say where you see the principles of electromagnetics in your daily life. Give me one example. Give me one example where you see the principles of electromagnetics in your daily life.
Hello, we are not able to hear you properly.
Okay, then
The
let
audio
me
is
try.
clear.
Were you able to hear me earlier? Were you able to hear me earlier? Okay. Okay. So let me stop interacting, and then which was the other place which got a good connection earlier? RV. RV, are you able to hear me?
Hello? Madam?
So able to hear.
Good.
Yeah. Do you have students there?
No, no students. I am a faculty. But your audio is not clear, ma'am.
Audio is.
Yeah, it's voice breaking. Lot of disturbance in your voice. Oh, from all colleges, they are facing the same problem from your side.
From all colleges. Okay. Lot of disturbance. JIS. JRS College of Engineering. Can you respond? Okay, let this question. Those who are able to hear me clearly, can you hand raise? All those who are able to hear me clearly, can you please hand raise? Recap. You are only ones who have hand raised, which means that my audio was clear. Can you please turn on the mic and speak? Recap, please turn on your mic and speak.
Hello?
Yes.
Hello?
Was my
Hello,
audio
we are
clear
able
to
to
you?
hear you, but yeah, we are able to hear you, but sometimes we have a break of the voice. Apart from that, the audio is okay. We are able to hear
You
you.
have audio problem there.
We are able
So
to
can you
hear
answer
you.
my question? Can you get some of the students to my question? Where do you see in daily life? One example.
Good morning, ma'am.
Good morning.
In the case of cyclotrons and mazes,
I can see you. You please talk on the mic. In the case of,
cyclotrons and mazes,
do you see cyclotrons in your daily life?
it reduces the acidity in vegetables too, ma'am. And in the case of cyclotrons and mazes, we use this electromagnetics, ma'am.
Did I hear you correctly? Did you say cyclotrons?
Yes, ma'am.
Do you see cyclotrons in daily life?
It's not daily life, ma'am, but we use it for
Use it for?
machines, machines.
In machines, in any machine that you see. Very good. All around you, if you look at, it's either a computer running, it's a microphone, it's a video camera, it's, or if you go into your home, it is a refrigerator, it is a television, it's an air conditioner, it's a micro oven. Any of those examples, if you pick, then electromagnetics that is working to make the instrument work. Okay, so historically, how do I get them to Zoom? I just wanted. So historically, we have always, in man's quest of finding the truth or finding how things are happening, the questions that we used to ask in very early days are, for example, why does it rain? Or why do the stars twinkle? Or why is there lightning? Or why do you have eclipse? These kind of questions. Now these days the questions that you would ask are, for example, how does a mobile phone work? Or rather, why does a mobile phone not work in certain areas? Why does the signal fall off in some places? Why would you have a microwave work only if you keep certain type of containers inside that? How is it that a microwave is able to cook only certain type of food? Why is it that we are able to, why is it that the FM breaks off its signal beyond the city limit? Why is it that the same frequency 98.3 for example is used by different cities and still carry different information? You can hear songs in Tamil, in Telugu and Malayalam in different languages at the same carrier frequency. How is it that possible? So these are the questions that I think people like you in this generation would be asking. And the answer to many of these questions you will get if you start thinking how some of these devices work. And to be able to understand how these devices work, as I said, all these devices use one principle of electromagnetics or the other. It could be either induced electric field, it will be either induced magnetic field, or it's a property of the time varying electric and magnetic field, which is creating some effect which is making your device work. I have a hand raise from PSG, so I'm going to start interacting with PSG. What is the dot? Okay, there we go. Okay, Peter, do you have a question? What I'm seeing on the screen is their video. PSG, do you have a question? Of course, if they have a question, they will talk. So, as the importance of electromagnetics, take the example of light. By the way, I work in the area of optics. My area of research is lasers and linear optics in optical processing or optical signal processing. So you do have lots and lots of electromagnetics principles applied if you want a laser work, or if you want a detector work, for example. Does C college have a in between? JSC college, do you have a question? I'm not going to bother about the questions right now. What I will do is to go back to my white screen and show you something simple actually. And I'm going to give you a minute to recognize where you have seen this symbol. This is an arrow with a curling arrow and a rhombus around it. This is the symbol of, or the logo of, IEEE. IEEE is, if for those who do not know, it's the Institution for Electrical and Electronics Engineers. It's a non-profit organization which has, I suppose, many lakhs of members with a motive of the goal of this organization is to support advances in technology. So an organization like IEEE, whose motive is to support advances in technology, you see there is no electricity, there is no magnetism, but the symbol they use is an arrow which shows electric field, current, a curly bracket which shows magnetic field, and a kite which shows the kite of Benjamin Franklin. Benjamin Franklin, if you go back and read the history, did a lot of experiments with kite to understand why lightning occurs or what happens when there is lightning. So such a large instinct towards the advances of technology is adopting electric field and magnetic field as the representative logo of the institution. You can imagine how electric field and magnetic field are contributing towards the advances in technology. Right? So the importance is cannot be overemphasized. I'll give you an example or a thought problem. Let us say I have a source, electric source, a sinusoidal source, which means it could be a signal generator which is giving you a voltage V0 at a frequency omega. Let us say you are connecting this to a load a resistor. So this is a sinusoidal source. So this is giving you a voltage V of t, voltage varying as a function of time as V0 cos omega t. A sinusoidal voltage, if I plot it, it's going to look like this at t equal to 0, and depending on my omega, I would have this voltage varying sinusoidally. The question I'm asking is, at a certain instant of time, if the voltage at this point, if I put a multimeter and measure the voltage across this A prime, if that voltage is, let us say, V of t, at period measured across A prime, this is what is given to you. Question I'm asking is, what is the voltage that I would measure? Let me call this voltage as VAA prime as the voltage that I measure across AA prime. Question I'm asking is, what is VBB prime at the same instant of time? Think about it. What connects this is an ideal conductor. Okay, an ideal conductor is connecting the source and the resistor. Your electrical circuits class would have taught you that your VAA prime is equal to VBB prime because it's a short. There is no voltage difference, but it is not always true. It is not always true because you see, we drew this, let me draw that again. We drew this sinusoidal voltage V as a function of time. Let us say this T1 that we are talking about is at this point. You see, the wave would take a set amount of time to go from this AA prime location to the BB prime location, right? And the best time that we can think about is 3 into 10 power 8 meter per second, which is the speed of light. So even if it travels with the speed of light, it is going to take that much time. Even if it is very small, it is going to take that much time to reach from AA prime to BB prime. Which means, in this scale, if the time taken is, let us say, delta t, how would I calculate that time? I will use the formula speed is distance by time. So my delta t is the distance, which is this distance. Let us say L is the length of the line, L over C. So even if this t is very small, there is a non-zero delta t. This delta t is not zero. It is zero only if the length is zero. Which means what I see at BB prime at a time t is what V naught cos omega t1, which was the time that I have considered, minus L by C, because you see that is a time delay that I would have at L by C before, which means this is not equal to VAA prime. Now, if I expand this and I can calculate what is this L by C, in which if I say my distance is 1 meter, then it would come out to be some nanosecond. But if the separation between the peaks, if my omega is of the order of gigahertz, which means my time period is of the order of nanoseconds, you see gigahertz is, I'm just talking about order of magnitudes here. Gigahertz is 10 power 9 hertz. Corresponded would be 1 over this. So this would be around 1 nanosecond. And if this separation is 1 nanosecond, and if my length is say 1 meter, or to make easier calculations, let's take it 3 meter, so that delta t is 3 meter by 10 power 8 meter, which is 10 power minus meter per second. So this is 10 power minus 8 seconds, which is 10 nanoseconds. So if I have a sinusoid which is changing phase, or if where the period is 1 nanosecond, but a 3 meter length of wire, you have a propagation delay of 10 nanoseconds, that would mean that you would have, like this, you would have the 10th peak. If at T1 the VAA prime is at the peak, Only after the 10th peak would you have VBB prime. The phase is different. The voltage could be different. So it simply means that I cannot ignore this line, the length of the line, if my frequency is large. Think about this problem. Maybe in the next session we will discuss this problem again, and I will tell you how to account for this delay through circuit theory, because we are familiar with circuit theory. So I stop this session here. Now I will keep the class into questions. So please hand raise if you have questions. BK,
Madam, I want to ask one question. Where we can get exact boundary that we can say that above this we can do distributed circuit analysis, below this we can do lump circuit analysis.
So I will discuss in the next class. Today I gave you an example. You have yourself seen that what matters is the delay, delta t. So if my delta t compared to the time period is very small, then you don't worry about the delays. Effectively your voltage at AA prime and BP prime are identical. So when the period becomes, either when the period becomes small or the length becomes large, we will come up with a condition as to when should I apply a delay concept and when should I not apply the delay concept. That's the first thing we will do in tomorrow's class, in Thursday's class.
Okay, thank you very much.
Right, you?
Hello?
Do you have a question? Yes?
Madam, voice is not very clear. Your voice is not very
Okay, so that is something I as a teacher cannot help.
maybe
I am going to speak as clearly as possible here.
it appears that microphone is placed very close to you.
Feedback
Yesterday
from your
also,
side, I can hear. I can hear my voice getting back to me.
okay. Thank you, madam. Thank you so much.
Is that proceed?
Thank you, madam. Thank you.
Any other colleges which have questions, please hand raise.
Thank you, madam.
Okay.
Hello? Madam, can you put your slide on your website that we can access your PPT slide? The study material for today.
I really don't. I do not believe in teaching through PPTs. So what I can do is I'm using this OneNote for writing. I can share that OneNote with you if you think that will be useful.
Okay.
Hello? Hello, madam. Do you hear me?
GIT?
Yeah. Hello, madam. Good morning
Yeah,
to
can we
you.
interact?
Yes, right now our students are not there. Our term reopens by 1st February. So next week we'll be having students with us.
1st
And
February,
then,
okay.
through the interaction
Okay.
on the screen right now going on, what I feel is you are making it very interesting. Like circuitry, all of us know in a greater detail. So through the circuit concepts, I think you are trying to explain the concept of electromagnetic field. That is very, very nice, madam. Thank you.
Thank you. Thank you. I hope students would like that. Thank you. But the audio and the visual subject is clear?
The using, madam, we could not see it, so I don't think couldn't be able to write anything into their papers when same thing continues next week. So that whiteboard what you're using for demonstration, I don't think we are able to see it.
Yeah.
So if it is visible, I think it will add on to the
Just a minute,
better
I have a
transmission
technician
of the
here.
concept.
Okay. Can you please raise this issue as an issue through your to QEEE technical staff through email? They will tell
Yeah,
you
sure,
how to do it.
sure. Yeah, sure, we'll do
Because
it. We'll do it. Yes,
I will be
definitely.
happy if you are able to see the whiteboard and not my face, right? So
Yeah.
if the connection to that whiteboard is very critical, or I'm not going to be using any PowerPoint, so it is going to be only through that whiteboard. So please make sure that you're able to access that.
Yeah, sure, sure. Thank you, sir. We'll do that definitely. Okay.
Thank you. Thank you. If any other college wants to connect, I'm closing this session now. Meet you again on Thursday morning at 8 o'clock. Dr.